Jeez, man. Yeah, so my previous stream just died. That's brutal. Let's see, is this still working? Hello, hello, hello. My previous stream just died. That's brutal. That was rough. Oh, that's rough. Okay, let me see. Oof. Boy, I gotta breathe here. Let me just take a look at the previous stream before I continue with this one. Gosh, man. I'm pretty disappointed. Yeah, 40 minutes, 55. Okay. I was just gonna do 40 minutes. 40 minutes. Yeah, my stream keeps dying. Oh, it's brutal. That's so rough. Okay. Well, that's a rough one. I'm gonna try to get through this one. See, this one's still. That's a rough one. Yeah, it's still alive. Yeah, so I didn't even notice that the stream died before. That's so brutal. Okay, we'll go back and look at the last two questions. So, remove outermost parentheses was a pretty clever approach. Let me do the last three questions just quickly so folks could see it. So yeah, the number of laser beams of the bank, we went with a transform for the row, and it basically was the previous row times the current row, and then you would just skip rows that were empty. And that was the basic idea. I used a raw loop because it was a little bit easier for me to kind of think about it. Then removing outermost parentheses. In order to get the primitives, I would use a check. So I'd use a string result and a count. Each character I would check and see if it's an opening parentheses. I would skip in certain conditions, and then if it's an opening parentheses, we would increment. If it's a closing parentheses, we would decrement. And then if we're not skipping, then we push the result back. The reason times you'd skip is when the count is 0 and it's a check, so you're entering a new primitive, and then also when you're leaving, when the count is 1, and it's a closing parentheses. And in those cases, you skip adding the parentheses. That's basically those denote when you're beginning and ending a primitive parentheses. So for this one, that was a reasonable solution. So I did that one. Let me just check the stream hasn't died. Stream is not dead. Okay. Yeah, it just dies on me every now and then. And then I was working on this one, the prefix common array of 2 arrays. And the solution I came up with, I think, was pretty clever, but kind of on the slower side, as it turns out. And the idea was to use unordered sets for A and B, and hold on a second here. Unordered sets for A and B, and well, there are a few things here to point out. Let me just see. Hold on a second. Oh wow. Okay, that's great. Lights went out. Unordered sets for A and B, and the idea would be at each position, you can check the sets against each other and see which values match. So you'd have like when you see a 1, you put that into A set, and you see a 3, you put that into B set. When you see a 3 in A, you check it against B set. If they match, you pull them both out of the set. When you see the 1, you pull them both out of the set. And in both cases, when you pull it out, you increment the count. And so you'd have zeros initially, and then you'd have 2s for this spot, or 2 for the spot. Then you see 2 and 2, and 4 and 4, and it works just that way. Yeah, and that works just fine. And when you see a match, you don't add it into any sets. When you don't see a match, that's when you add it into the sets. And this works. This is correct. There are a couple things I got to do. I'm going to do in a minute here. Let me go ahead and let me optimize this a bit. So this could be a further optimized in a couple of ways. So the first way this could be optimized is by, can I please, there we go. First way this could be optimized is by using for the hash sets, you could actually use a more sophisticated approach, which would be just like a highly optimized hash set. It's okay. Highly optimized hash set is okay, but I wouldn't recommend it unless you like really want like a super fast solution. It's not really worth doing, quite frankly. Another approach is to use just a regular set, which might be a little bit faster. Let me see if that's any faster. That could be faster, I'm not sure. Let's see if it is. I think that's still correct. Let's try it. So I'll use a tree set. It's not much faster. I gotta wait a few seconds. There's yet one more approach, and that's actually to use an array instead of maps, and use std_find. So you could use sets, or you could just use std vectors, which is a little more interesting. Since there's a very small number of elements for both of these, it's a little bit easier. So you would say, instead of using a hash set, you do something like this. It's going to be std_find. Oops. So a little bit more involved. And you do something similar here. And this might actually be a little bit faster. And then so, instead of inserting, you just push back. I gotta turn that light back on. Okay, something like this could work too. Forgive me, a little bit distracted here. All right, is the stream still on? Yes. Okay. So this looks like it's still correct. Let me try it and see if it works. Yep, okay. So that's a little bit faster. The reason it's faster is these arrays are small. Can actually do a little bit better too. You can do observe, data size. I think this works. You could actually make these static, I think. I don't know if static's a good idea. We'll make them static for now. Maybe we'll optimize it a little bit more if you make them static. Not entirely sure. Yeah, I think if let me just try one more time. Let me see the time here. There's a bunch of things I gotta do here. 10 minutes in. I think if I make them static and then, okay, it does, how can I clear vector without removing the memory? This is the clear this. Because these are so small, it's 50, right? It's at most 50. I can make this static, and I could do like static 50 0 50 0 50 0, or just -1. And then remove the values. Okay, so you can clear it. Yes. Okay. So just clear these two, I think. So this will reuse the memory and should make it more efficient, I think. Hopefully this works correctly. No, it's not faster though. All right. It's reasonably fast, but not quite fast enough. Not actually fast enough. That's kind of annoying. Correct. Oh, there it goes. Okay. There you go. 100%. Okay. And uses a lot less memory. Yeah, that's one of the keys to being fast, is using less memory. All right. Let me go turn the lights back on here. This is like, it's a little ridiculous. I'll read this while I do that. Final array state after k multiplication operations 1. Nums, integer k, multiplier, perform k operations on nums, each operation. Find the minimum value x in nums. There are multiple occurrences of the minimum value, so that appears first. The 100 numbers, their values between 1 and 100. K is 10, multiplied to 1 and 5. Everything's kind of small. K operations on nums. Each operation, find the minimum value in x and nums. If there are multiple occurrences of the minimum value, select the one that appears first. Replace the minimum selected value x with x dot multiplier. Turn integer array denoting the final state of nums after performing k operations. Okay. So here's the minimum. Here are the minimum values. We're gonna have k is 5, multiplier 2. So 2 becomes 2. Then 2 times 2 becomes 4. So 2, 4, 2, 3, 4, 5, 6. Or yeah, 2, 3, 2, 3, 4, 5, 6. Then 2 again becomes 4. So 3, 4, 4, 5, 6. And then I think there's one more, gives you 6, 3, 3. Yeah, 6, 4, 4, 5, 6. And then 8, 4, 5, 6. Okay. And the output, and I guess the indices themselves. Excuse me. Oh, we don't take anything modulo. Well, 5 to the 10th could be pretty large. But I guess all the numbers are fit into integers. Okay. All right. So that's not too bad. I mean, the easiest way to do that is just to use a set. Instead set. I'll explain how this works in a moment. Vector. Actually, yeah, we're gonna have a struct here, and this is a bit complex what this is, but this is basically a functor, I think. Or something like this. I don't remember exactly what this is supposed to be like. It's something like this. Mm-hmm. Excuse me. Custom destructor. Set of integers. The indices, right? Yeah. Yeah, it's confusing. And there's something like this. I don't remember exactly. What is the return value? Let me just see if this even compiles. I don't remember how to do this exactly. It's been a while. I should go turn this light on. Check that the stream hasn't died. Let me let me see if that's any faster. Yeah, it looks okay. What does it say? Type specifier, all declarations. I think it's turn it int. I don't know. Compiler. What is stood set custom comparator or a custom key something or other. Functor lambda or function pointer. Okay, functor is most common. That's what it is. Okay, custom compare. Got it. Yeah. Oh, excuse me. You can't use the template argument directly, but you can pass them to the constructor. That's what I want to use. Okay, lambda. Comparator must return true. Strict weak ordering. Equivalence is defined. Okay. Yeah. Okay. I forgot exactly what this is supposed to be. I think I prefer the lambda approach. Auto compare. And we're gonna say declare table type. There. Yeah, I like this one better. And then we can do Let's just see if this compiles. Oh, okay. Oh. All right. Wrong answer. It compiles though. All right. So this is what I want to do now. Using a set defined this way, what can be done is for each value of k. First, so we're going to add those values in like so. Then we're going to say for int 0 access to k, excuse me, increment I, or just, excuse me, well, k is greater than 0. That's another way of doing it. Increment k. We're going to go ahead and did I screw you out of there? Excuse me. Just going to say indices dot, so auto iter equals indices dot begin. And we're going to indices dot remove or erase. Say first count or int val equals iter indices dot erase greater. And then we're going to say val multiplies equals multiplier. And then we're going to say, oh, no. Or current index, we'll say. Okay. And we're going to say constant. We're going to say nums of current index multiplies equals the multiplier. And then we're going to indices dot insert index. Okay. And then going to return nums. Something like this. It's a bit confusing, but something like this. All right, this is wrong. So output 8, 2, 6, 10, 6. Oh, you know what? There's an issue here. Yeah. Okay. One that appears first. So actually it's, oh, okay. Got it. It's a very subtle thing here. Okay, it's going to be or, oops, nums of A equals nums of B, and A is less than B. Very subtle, but if the values are equal to each other, then sort them by the indices. There we go. Okay. Let's give that one a shot, see if that's correct. Live stream's not dead. That's good. There we go. So that's one way of doing it. I mean, this is a slower solution. It's faster to program. It's very straightforward to program, but it's definitely not the fastest way to do this. The fastest way to do this is probably to use a heap. But the problem with using a heap is that it's kind of complex to program. Like there are a lot of extra elements to this. Create a heap. Well, I guess I could try using a heap. Let's see, C++ heap. Let's see, let's test some coding abilities here. Let's see. Would you kindly Okay, hold on. Of course. All right. Would you kindly convert this code to using a C++ heap instead of a C++ set? This is this is fine. It's a little bit easier to use a set because it's just a little bit like more straightforward to program, as you saw. But using the heap, also priority queues are not so obvious exactly how that works. So I can make the heap make a heap. Push back, push heap, reheapify, pop heap, pop back. Oh. Yeah. So let's actually use a heap. Let's write my own heap implementation here. Indices. And this is going to be numbers.size 0, stupid Yoda, indices.begin, indices, and 0. And I'm gonna use the same comparator, but use a different, not use the set. And we're going to std make heap. And this is going to be begin and begin. And we're going to use compare. And then come back to this part here. So this is going to be auto top is equal to yeah, pop heap, which is going to be just the top of the heap. So it's going to be indices of 0. Then the current index is going to be top current index. And then we're going to go ahead and erase. So pop. We got indices step in, and this is an int, by the way. And I want to say we use this comparator pop heap. Then current index multiplier, and then insert again. So push back into the heap. And then push heap. Push back and push heap. And push heap. Confusing, but something like this. Let's see if that compiles. Wrong answer. Okay. All right. Okay. Priority queue. So they're saying priority queue and lazy updates. Interesting. Huh. I wouldn't have used that one. Okay. Make heap indices. Iota. Okay, so I did that. So pop heap. Put it on the back. Push heap. Oh. So I have to maintain, it doesn't reheapify based on updated values. Oh no. You need to maintain the heap manually. Yeah, that's the part that's annoying. Stick with stead set. Use lazy priority queue. Yeah, manually reheapifying is really annoying. You can do it, but it's just a pain in the butt. It's a lot of extra code. Okay. Shoot. Correctness and simplicity. The original set version is clearer. Yeah, that's why I like that one the best. Yeah, I've seen questions like this a few times now, where like in an interview setting, you'd want to just use the set approach. Try and do it quick, use the set approach. We could try lazy priority queue. Could try that. See how that goes. So priority queue, decal type comp PQ. Let's give that a shot. See if that's any faster. So it's going to be just stood priority queue int vector int decal type. Okay. I rarely use this data structure, if ever. So it's not as familiar to me. Decal type comp. Okay, PQ comp. All right. And then push all indices. So we're not going to iota. You probably could iota this, but we're not going to do that here. Okay. EQ insert. Push all indices. Okay. Track how many times each index has been updated. All right. Vector version, nums not size. Okay. Not quite sure what they're going for here, but all right. Version. Okay. Q greater than 0, decrement K, or K is greater than 0, decrement K. Now what do they do? This entry is stale. So we're going to PQ top, PQ pop. Okay. So pop the priority queue. If the version of current index is not equal to 0, if version of current index is not equal to 0. Skip it, we'll have newer ones in the queue. So increment this version. I don't know what's going on here. PQ.push current index. Continue. I don't know. What does that do? Re-edit. So if the version is not equal to 0, apply multiplier. So it's going to keep popping and pushing until the version that's 0. And then eventually we're going to get something that we can update. I don't think that's correct. That doesn't seem right. Nums current index line times equals multiplier. Increment the version. And then push. Oh, current index. Okay, I need to. Oh no, shit! I need to charge my computer. It's gonna die. Give me a moment here. Also, yeah, give me a moment here. Hold on. Turn the light off too. Oh, super. Okay, I think that's better. Sorry about that. All right. Let me see. Oh, okay. All right. Let me see. Okay. Oh, all right. Gosh, man. Okay. So, we're doing time. About 40 minutes. I want to go for like an hour and 20 minutes here. Oh, right. I don't think this is right. By the way. Okay. I think it's just push, not insert. I don't think this is correct. Yeah, this is not a correct solution. code you gave me is not correct. Look at this, like, wait a minute. Uh-huh. Hmm. Hmm. Oh. Oh, okay. We go back to my heap version then. Jeez, man. I was like, oh, I'll use a priority queue. Okay, this will be great. No. Jeez, man. Okay. All right. All right. So this isn't right. Okay. This one is wrong. You show me what's wrong. I think I know what's wrong, but I'll just ask the AI, see what it says. Oh, creates a max heat. Ooh, that's subtle. Whoops. Oh, well, there you go. I actually kind of forgot about that. Min heat, max heat, it works a little bit differently. Whoops. That's subtle, huh? Oh, that was the issue. Oh, so my code was right the first time. All right. So I was wrong about the heaps. Oh, gosh. All right. Well, learn something every day, huh? Um, that's actually pretty significant. So, also, how are we doing with the live stream every day, huh? Yeah, it's actually kind of a big deal. So heap works nicely here, and you can use the C++ heap code. Oh, that's good. A couple issues that I had. One issue was that um, let me get rid of this extra stuff here. That's really interesting, actually. Let me do this. So I like this heap version better. Definitely better. Much better. Let me talk about it. There's a few things to say. Okay, so first things first, it's the fastest solution. It's pretty good on memory. Second thing, I can do this instead. Um, hmm, very interesting. Okay, there are a few things to say about this. Number one, it's fast. And it's clean. It's fast and it's clean to program. Number two, it is very similar to the set version, except the set version is a little bit slower. And the important difference, though, is the comparator is different. So if you use a greater than comparator, you'll get a min heap. So further down the heap are the larger elements. That's how the comparator works for heaps. There are some heap built-in algorithms which are very nice here. It's definitely easier to use the heap, I think. It's easier, it's cleaner, it's faster. The actually here is the push heap does actually work correctly. I thought that you had to manually update the heap incorrectly. I thought you had to manually update the heap, but you do not if you're using push heap. This will perform the reheapify correctly and I think efficiently too, which is pretty good. So that's good. That's really good, actually. I didn't know that. I think I misunderstood how this works in C++. So that's awesome. It'll reheapify automatically, pushing the back. Actually, the main issue is that it's, I think I just had to get the wrong comparator when I would do this in the past. And so it's actually pretty straightforward to just get the index, pop the heap, pop the heap and pop the value, and then perform the operation, then push in the back, and then push heap to reheapify. And this will basically just push the last element, just reheapify the last element. That is awesome. That's really cool. Okay, this is cool. I'm glad I finally learned how to do this properly. Oh my gosh. Oh my gosh, man. It's been a while. I don't know, dude. I miss a lot of things that are important. I do. That's kind of sad, but yeah, it's what it is. Awesome. Yeah, so that's a good solution. I like that solution a lot. That's probably one of my more appreciated solutions. There are versions of this question, by the way. I've solved this question, like harder versions of this, and they're not really that too hard. This approach is only part of a broader solution. But yeah, that's a very low acceptance rate, the broader solution. Yeah, I'm kind of proud of this. This is actually, I mean, it's very simple, but I'm also kind of proud of it just because it's very concise, straightforward, clean solution. Also gets the 100% mark, which is quite nice. So yeah, I like that. It's good. But yeah, there's a harder question that builds on this solution, or builds on this question, and you can use that solution as part of like a subroutine. All right, how are we doing overall? All right, it's been 48 minutes. I want to go to like an hour and 20 minutes. Chat's doing okay here. Live stream is still live. That's good. All right. Running some array. Let me keep my voice down here. Okay. Given array nums, we define a running sum array as running sum of I equals sum 0 to nums of I. Turn the running sum of nums. Nums 1, 2, 3, 4. Output 1, 3, 6, 10. Running sum is obtained as follows. 1 minus 2. Oh, so this is partial sum. Okay. Yeah, this is a very straightforward question. This actually is just like an algorithm in C++. So this would be return. I think it's stood partial sum. I think it's what's called partial sum. And it's just going to be nums.begin, nums.end, nums.begin. And I think that's it. It might be it. Save it. Yeah, that's it. Yeah, I mean, this is just like a straight algorithm from the straight out of the STL. If you're wondering how to program that, it's you just add to the last value that you just computed, starting with the initial value. You just keep adding elements. It's a prefix array, prefix sum array. Function composition, give an array of functions, turn a new function, that is the function composition array of functions. Function composition of these is going to be f of g of h of x. Looks like it's backwards. Looks like you do the right to left function first. That's a little bit odd. Okay. Function composition of an empty list of functions is the identity function. So each function in the array accepts one integer as input and returns one integer as output. Okay, so these are one-dimensional functions, or technically two-dimensional functions. Okay. So input, oh, it's JavaScript again. Oh, god damn it. I was like, wait, how am I gonna do this in C++? Oh, that's why, C++. So, so, excuse me. It's a lot more complex than C++. So x times just 2x, then x squared, and you get 2x quantity squared. Then you get 2x quantity squared plus 1. And then you're going to apply it to 4. So here I think we're just applying the functions. Okay. Yeah. Oh my gosh, man. Okay. Okay, of course. Sure. Oh boy. I mean, I don't know. I don't know. This is kind of goofy. Sure, I guess. Literally just gonna be you just apply every function to x. Return the result. All right. For loop in JavaScript. It's been a while. It's been a while. Initialization afterthought. Oh. Does JavaScript syntax like C++. A container. 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 For auto. Yeah. Num of numbers. Okay. Const f of functions. And we're going to say result equals f of result. Can I do this? Wrong answer. Okay. It's close. 50. What is this nonsense? Oh, it's also backwards. So we're gonna do this backwards. I don't remember. Um, it's just reverse the format. It's fine. It's annoying, but okay. I'm not gonna copy the thing, man. That's too much. Dot length. Ah. Okay. How are we doing here? Is the stream live? It is. And okay, let's try this. All right. I said a minute, so an hour and 20 minutes. Okay, I'm not gonna go over this too much. This is a JavaScript thing. Okay, I think the dog wants some attention. It's actually not my dog. My family member's dog wants some attention. And oftentimes they're not available for one reason or another. It's very, very frustrating. Unfortunately, I'm not in a position at the moment to, I guess, not hide that or whatever, to express it. Gonna have to go take care of the dog shortly. Let me just wait a few more minutes. I want to take care of what I'm doing at the moment. Okay. Find indices of stable mountains. Okay. There are n mountains in a row, and each mountain has a height. For a given integer array height, where height of I represents the height of a mountain I, and an integer threshold. A mountain is called stable if the mountain just before it exists has a height strictly greater than the threshold. But that mountain 0 is not stable. Return an array containing the indices of all stable mountains in any order. So you got height 1, 2, 3, 4, 5, threshold 2, 1, 3, 4. Okay. So as long as the height is greater than the threshold. Wait, what? Off the mountain before it, just before it, if it exists, height strictly greater than threshold. Oh. What? I think it means that to the right of it is greater. So I'm a little confused. Oh, is it the index of the 0, 1, 2, 3? No. It's the index. Okay, that's confusing. It's the indices. Okay, all right. So we can use std filter, right? So we're gonna say, I don't remember exactly how this works. Actually, I don't know how this works. Depends on the version. Oh, export dog. I'll come back and take care of the dog. Copy if Okay, I could use filter or back inserter. I think a back inserter is probably what I want. Most compilers are pre C++ 20, I think. But you can still use filter. This works. Hmm. I like this. Let me try this, see if it works. Ranges, vectors. How are we doing with time here? Yes, I got 20 minutes. Live, stream still live, which is good. Let me do this one. I like this. It's kind of tricky though because of it's got to be the just before it, right? So we're gonna do std views. Okay. It's gonna be something like this. We're gonna do auto result equals height std views filter. Something like this. And then this is going to be index. Return. So I say this value. This is actually itself an index. If yeah. So it's going to be index const check. It's going to be the value is greater than the threshold. We're going to increment index. Return index. Return check. This isn't quite right. Okay. Let's do something else. Okay. We're just going to say, oops. It's greater than 0 and okay, height of current index minus 1 is greater than threshold. And actually, that's it. Okay. How about this one? Compiler. Okay. Like to excuse me. Turn filtered result as an array, as a vector. I might do this. I guess I need to dump it in. So it ranges to. Okay. View filter stood ranges to. Okay. Stood ranges to stood vector. How about this one? Oh, it works. Oh, that's cool. Let's go for it. Okay, let's get another 10 minutes here. Oh, I didn't realize the chat was going here. Hey, go on, bro. Hey, what's up? What's up? How is my? That's actually pretty significant. How's everybody doing? So, go on, bro. Hey. Okay. Let me. Oh, it still works. That's awesome. Okay, cool. Let me go take care of the dog in a minute or two here. This poor animal. I forgot the chat wasn't about the chat. Okay. I wonder sometimes if it works properly if I pop it out. Sorry, I'm just thinking about stuff here. So is this good? I mean, it works, but I mean, it seems all right. Yeah. Okay. Sure. Why not? Maybe better if I do this. Maybe like this. I kind of like this better. Yeah, I got 10 more minutes. Oh. Yeah, I don't know. It does weigh on my mind, the animal, the dog. She's kind of melodramatic though, to be fair. But also like it's not really good. It's actually really sad, the situation that I'm in here. It's not good. It's a series of unfortunate events, but I don't really want to share too much about what's going on. It's just I might need to get help at some point. I don't own those animals, and I don't want to say they're being neglected because it's not entirely true. It's more like the owners are not really, they don't really pay that much attention to dogs. And their family members, and I've kind of brought that issue up to them a few times. And the dogs really, dogs get pretty. What is that? Um, the dogs get pretty. I don't know what the right word is for that. Like, they get pretty like loud, and sometimes I do really need to go to the bathroom. And it's like if I don't take them out, it feels like someone's not gonna take them out. It's kind of a problem. I'm not really in a great position to do anything about it. Just upsetting. And I've brought it up several times with the owners. It's not fun. Not a fun situation to be in. All right. Okay, but in a few minutes I'll go and I'll go give the dog some attention. All right. Queries on number of points inside a circle. Given array points for points of I, x of I, y sub I is the coordinates of the ith point on a 2D plane. Multiple points can have the same coordinates. Also given an array queries where queries of j, xj, yj, rj describes a circle centered at xj, yj with a radius of rj. For each query, queries of j, compute the number of points inside the jth circle. Points on the border of the circle are considered inside. Return array answer of j is the answer to the jth query. Points, queries, output. Points in circles are shown above. Queries of 0 is the green circle. Queries of I1 is the red circle. Queries 2 is the blue circle. Green, red, blue. And what are they asking? 500 points. Queries length. 500 points, 500 queries. Coordinates are integers. Better than O of n complexity. Each query. It's a medium question. Multiple points can have the same coordinates. Okay, so each query is a circle. All right. Number of points inside the jth circle. Okay, that doesn't seem too hard. Excuse me. Faster than linear. I mean, yeah, a really simple linear approach would be to just take every point and check if its coordinates are within the circle by the circle should have a point and a radius. And then to check, you just use take the difference between the squared difference between the x and y coordinates and check if that's less than the radius squared. Basically check the distance between the center and then these points. So a way to do it more efficiently than linear in each one. No, linear in each one will work, but let me think for a minute. There's probably a way to do this using Delaunay triangles or what's the other one? Voronoi diagram. Voronoi diagram. Maybe. No. Um, I don't know a faster solution offhand. There's probably a computational geometry approach that's faster, but I just don't know it offhand. Let me. All right, I got a few more minutes here. I could program the solution to this, but it's not really the answer they're looking for because they're looking for this one. Oops. They're looking for this one. Um, hmm. Hmm. I think I know what can be done here. I think an online algorithm, in other words, processing all of the queries in one shot, is probably a more efficient way to do this. Um, that might be the way to do it. So if you see like these circles, if you sort them by coordinate and radius, and you process them in that way. So adding this, using this circle first, get the points, then shift over, and check and see which points you'd lose and which points you'd gain. Also, the points being sorted in a similar way. So you could probably do this in, maybe able to do this in like square root n time amortized per query by using, um, I think it's Mohs algorithm style sorting of the points. Um, Mohs algorithm style sorting of the points, and then do adding and add a few points, remove a few points each time you shift. Something like this. I think is the way to go. And you probably could process it in square root n time per query. I'm not going to do that here though. Maybe processing in square root n time per query is possible. I'm not sure though. There may be some other more clever ways to do this, but that's my guess. It's probably a Mohs algorithm type of thing, where it's effectively like a sliding window, where you order these points, and then also sort the circles in a similar way, and then you just kind of shift the circles over and kind of do something of a sliding window. It's a slightly less efficient sliding window. So you only remove and add like a bounded number of points each time. Just probably square root of n bound on how many points get added and removed. That would be my guess, but I'm not really sure. I'd have to think more harder about that, about how exactly it can be done. For now, though, we can just do a simple linear time algorithm. Okay. Yeah. Oh, there's. Okay. Oh, gosh. So, yeah, just loop through each point. Distance is going to be 0.0. Let's just do dx minus b 0 y. And then dx times dx is dy times dy. And then we're going to say count plus equals distance. These, those are say d2 is less than or equal to d2 times d2. Say results. Ooh. Like that. Okay. Maybe a better way to do this, but this is okay. I'm sure there are better ways to do this. Yeah, I think this will be the last question, and then I'll get going here. I can hear the dogs like wallering over here. All right, let's see. Or not, well, they stopped, but they were. Yes, this is not the most efficient way to do it. As I mentioned before, it works for this question, but the better approach is probably uses, not only could this be probably optimized a little bit better, but also I think probably a Mohs algorithm style optimization to get more of a square root of n per query is probably doable. But I'm not sure. I guess I'd have to think about it a little bit more. Spend a little more time on this, which at the moment I'd prefer not to do. So yeah, thank you everybody for watching. I think I'm gonna stop here. Yeah, I'm a little bit bummed out thinking about the dogs. It's actually a really pretty awful situation to be in overall. Like really stresses me out. I've talked to the owners like I don't know how many times. I've like lost track how many times I've mentioned said something. And I'm probably gonna have to get like other people involved, which is like very, very upsetting and depressing and frustrating. Actually, this has been going on for like years now. I've been taking care of these dogs where it's like if someone were to spend this much time taking care of animals, they get paid probably like $100 a day because it's like 3 to 4 times a day that you got to take care of the dogs, pay attention to the dogs. And having someone come out to your home to take care of your animals 3 or 4 times a day is really expensive. It's just overall really, really frustrating. And the owners, I don't think, understand what they're doing to the dogs. It's not really like good. That the dogs require more attention than what they're giving them. So it's not really like I don't want to say they're mentally ill. It's not maybe not accurate, but like it comes off like they might like the owners might be mentally ill. Um, which yeah, it's like an extremely difficult position to be in, extremely uncomfortable. Um, sorry, I mean I didn't really want to share that publicly, but like how else would I explain like dogs, basically howling in the background. All right. So yeah, thank you for watching. Pretty bit of a bummer to end the stream on here, but got through some interesting questions. That was good. Let me get going here, and um, yeah, I think, like I said, I think Mohs algorithm is probably what we're gonna want for this. But for now, I think I'll just stop here. So yeah, if you like the stream, don't forget to follow, and yeah, got some got some problems done today, but it was okay.